is this one. How many tried this already? Not many. I don't know why you wouldn't. Waiting for me to try it for you is not a good strategy. Just so you know. So, you know this is a question number 2, and it's going to be outrageously looking like this. If you look at every question number 2 in the testing manual, they look like, oh my God, we never saw anything like this in the test. Yeah, it's welcome in the wrong spot. Right? That's the way it is. I don't believe in just giving you book problems. So, right away, I see springs in series. My mind says 1 over K1 plus 1 over K2 equals K, 1 over K equivalent. My mind instantly says X1 plus X2, or in this case, K2 plus K3 must equal to K equivalent. Right? I see something that's got dimensions, which means, hey, I gotta treat this as a rigid body. When I have a rigid body, the first thing that pops in my mind, hey, there must be a moment someplace, because there are forces. You got this block, has some weight. You got some cable tension. So I got 3 forces on this beam. So there's probably a moment in here. And then, of course, I see a 2D. I see a 2D where I have a concurrent system here at G, right? So some force X, some force Y equals 0. So here's where I've taken a little bit of this, a little bit of that, from chapter 4, chapter 3, etc., and threw it in and mishmashed it and threw it at you. Yeah? And then, of course, I did see a block on an incline. Did we cover blocks on inclines? Yeah. Now the question is, what the hell did it give me? What kind of information do I have? Well, it says, for the system shown below, the weight of block B. All right, so I have block B is 50 pounds. My suggestion to you is you go in here and put the actual number associated with whatever you're looking at. That way you can visually see it. Block E is 125, so that's the block that's on the incline. Right? Spring constants for K1 and K2 is 25 and 50. Please note the little details. Pounds per inch. What do I have here? Feet. So be careful with the pounds per inch and the feet stuff. So what do I have? I have, what is this? K1. Where's K1? There's K1. That is 25 pounds per inch. And K2, which sits right here, is 50 pounds per inch. Great. Then I have a magnet. There's the moment. 1720 at D. Then, that's all the information I have. Of course, I do know the angle is 25 degrees here. Find me the maximum amount of the spring K1 can be stretched. Well, for me to find the stretch, I gotta go to Hooke's law and say F equals KX. You're asking me to find K. That means I need the force in that. Once I have the force, I divide by the 25 pounds per inch in the appropriate units, and I'll have the X that it's asking for in part F, right? The normal force exerted on the block E, that's the easy one. And then see the spring constant K3. If springs K2 and K3 are stretched a combined distance of 10 inches. So I have the stretch in the spring. The question will be, and this will be the question for you on the test, where the hell do I start? Where should I start? I got lots of information. Where do I start? Well, I would say I like this point of concurrency, but if I draw my circle around that point, I will cut through three things. Correct? I'm going to cut through this one. I'm going to call this TE, because it's going to lead to E. Right? I'm going to call this TC, because it's going to lead to C. And this I'm going to call FA. Yes, there's a spring. I know there's a force in the spring. Just going to call it FA. What's the problem there? Right away, you see a problem. What's the problem? Huh? Three freaking unknowns. Well, that doesn't help me. That kind of sucks. So yes, I can write the equations, but I ain't going to solve it. Correct? And then you say, well, what if I start on this member A, B, C, D? Okay, I have the moment, so let me maybe write a moment for this. So if I draw a free body diagram, I should show a force, FA. I already know this force is 50. This force is FC, right? Well, crap, that's another problem. Two unknowns with only one equation, a moment equation. Correct? Now, think about this. I have three unknowns if I write for G. Right? Three unknowns. I have two unknowns if I write a moment. However, this guy and this guy are part of that. So what happens here is, what I've done is I've made you the layer of gratification in getting a number. You're going to have to write whether you start at G or whether you start at D really doesn't matter. Well, the bottom line is I need to do both equations for D, for A, B, C, D, and I need to do G. And then I'll have three equations and three unknowns in order to solve it. So what you're used to is writing equations, boom, getting a moment, or getting a force from the moment equation. That's what you're used to. This time, I played the game of, I'm not going to let you get the force when you write a moment. I'm not going to let you get a force when you do the concurrent point G. However, when you combine the two, now you got something. So, let me start. And it doesn't matter whether you start by writing G, equations for G, or the equations for the moment. I'm going to do the moment. So I'm going to draw a free body diagram, A, B, C, D. So in essence, what I'm doing is this. I'm going to cut through here, cut through there, come all the way back. Wherever my pen has circled and cut, I got to show as a force. So here's the beam. I have to show a force that I'm going to just call FA. It doesn't matter what you call it. I'm going to show a force of 50. I'm going to show a force C, FC. And then over here at D, I have 1720. So I'm going to write some moments at D, clockwise positive, is equal to 1720, which must equal to the moments being generated by these three forces. That would be FA times 6, 2, 4, 6. FC times 2. FC times 2 minus a 50 times 4. And that must equal to 1720. Simplify 6FA plus 2FC is equal to 1920. There's equation 1. So I wrote a moment equation. I didn't get anything. Now you're a little like tense, like, oh shit, did I do something wrong? I didn't get an answer. No, you didn't do anything wrong. The problem is set up that you can't get any answers with writing the moment equation for ABCD or the force equations for joint DG. But if you do both, then you don't have enough equations up on notes. So I am playing literally a game with you. That's what I'm doing. I'm trying to see, are you confident enough that you can go ahead and say, I didn't get an answer, but I'm going to go on and write the next set of equations. So I'm playing a game with you. And honestly, I'm kind of foreshadowing what's going to happen in chapter 5. Chapter 5, you're going to write a force X, a force Y, and a moment. And that's exactly what you're doing here. Force X, force Y, and a moment. What?
What are you doing?
Doesn't matter. We know it's 1720. So I'm going to set this equal to 1720. Whether it's clockwise or not, it doesn't matter. Next, I'm going to do free body diagram at G.
So we don't have to worry about the versions. If someone comes, like we don't have to make.
Well, right now, this one right here is no big deal because this moment is in pounds feet. So these are all in pounds, so I got no problem. There's no missed units on this one. So here comes G. I cut through this cable, I cut through that cable, and I cut through there. So I'm going to show an FC, an FE.
Could you move this, please?
Yup. And an FA. Yes?
You still can't see it.
You still can't. And I'm going to put in my coordinate system. Standard. Nothing unusual. Y, X. And I know this angle is 20 degrees by alternate interior angles. I know this angle is 15 degrees by alternate interior angles. These two are up here. So I'm going to write some forces in the x equals 0, positive to the right. That's going to be FC cosine 20 minus FE, that's the new one that popped up, cosine 15 must equal 0, or FC is equal to 1.028 FE. I didn't get an answer, but I got another damn equation. That's equation 2. Do not panic. I sometimes play games with you on the test. I'm testing your resolve. A lot of times what happens is, you may start over here at ABCD, and because the data is given in such a way, you may have to jump to here, and then back up to there, but eventually everything will have its answers. Everything will generate equations so you can solve and get answers. So don't just expect to go, okay, I'm going to start here and I'm going to work my way this way. Or I'm going to start here and work my way that way. No, you may start here and then jump over here to get something in the middle here. That's me playing with your mind. Okay? Next equation. Some force is in the y. Some force in the y, positive upward. That's going to be FC sine 20 plus FE sine 15 must equal to FA. Or minus FA equals 0, same thing as saying equals FA. Agreed? This is 0.342 FC plus 0.258 FE is equal to FA. Now, please note, what do I really have now? Unknowns. FA, FC, FE. How many equations do I have? I have 3 unknowns. How many equations do I have? 3. I proceed to solve this. Okay? So you had to delay your gratification until you got all 3 equations written. And now you can solve and say, hey, FC is equal to 345.448. FA is equal to 204.85. And FE is equal to 336.12. All in pounds. So now you solve 3 equations, 3 unknowns, and get your answers. Nice. Any questions? Any concerns? How many that tried it got these answers? 1. I got 1, 2, 3, 4. That's it. What do you mean? No, there is no this. You tried it but got it wrong. Okay. But at least you tried it. Some of them sitting in the audience didn't even try it. This is the first time they've seen it. You don't understand. Human beings learn by failure. You should have tried it, and if you missed it, at least you could go back and say, that's what I did wrong. Now you're learning. We fail more often than we succeed, if you want to know the truth. When you learn to ride a bike, how many times did you fail before you got it? So you got up and you wobbled and got up, wobbled, and that's failure. You failed at riding a bike. Some people it takes 5 times, some people it takes 10 times, but you failed until you figured out how to balance. And then you're successful. True? Any questions? All right, now, it did ask me, hey, tell me the X1 for this spring. Well, now that I have the force in FA, which is this right here, I can now say 204.85, this is Hooke's law, F equals KX, is equal to 25x1. Therefore, x1 is equal to 8.19 inches. Remember, the force is in pounds. The K was in pounds per inch. Therefore, x 8.19 is in inches. Yeah.
Are you taking off points on the test if you don't like this?
I usually don't take off points for not writing units, but if I see you get something different than this, it's because you didn't convert properly. I will take off for that. Okay? All right, so in essence, for me, all this is now bullshit. I don't care about it anymore. It's not important to me. I'm moving on to the bottom portion of it, which says, let me draw a free body diagram of E. Well, free body diagram of E says I've got this block, and I'm going to put my coordinate system. What we say about coordinate system for a block on an incline? Tilt the coordinate system, makes life much easier. Here's y. Here's x. On here, I'm going to put in my normal force, which part B said, find me the damn normal force. Here's the weight, which I already know is 125 pounds. This angle happens to be the angle of the incline, which is 25. I know there's a 336.12 from FE that I calculated already from the previous. I'm carrying that with me. And last but not least, I've got some sort of spring force, FSP. And I know there's two springs, but I know I can combine them into one. So I should have one spring force. I call it FSP because I don't know what it is. Normal force is easy. Now, usually I ask you to do a normal force so I can throw points at you. Literally, that's what I'm doing. I'm saying you can fuck up everything, but at least you can get a normal force and I can give you a point. Right? Because the normal force is easy. All I have to do is say some forces in the y equals 0, positive in that direction. Well, there's only two things. That's n minus, this has a component this way and a component that way. And I'm looking at that component saying 125 cosine 25 equals 0, because that's the only things that are in the y direction. N therefore is 113.28. And trust me, on the test next week, there is a block on an incline. And I'm going to ask you, find me the fucking normal. That way I can throw a point at you. Or half a point, depending on what the problem, the point distribution is. So you should be able to get that, because it's nothing more than this, whether it's on this problem or any other freaking problem I give you. So this is me throwing you some points. Pick up those points. If you know nothing, at least do me some forces in line, give me a normal. Get a point, half a point, something. Okay? Next, I'm going to do some forces in the x. Some forces in the x equals 0. Positive down the incline. That's FSP minus 336.12 plus 125 sine of 30 equals 0. Oh, 25. Yep. So I've got this one going that way, that's negative. I got this one coming this way, this one coming this way, positive, positive. So guess what? FSP comes out 283.29 pounds. Now, I can say, hey, Hooke's law again, F equals KX. FSP is 283.29 is equal to, there's two springs, I'm going to call it K equivalent, times 10 over 12. I don't know why I converted, because I could have used the pounds inch instead. That's a CF, a conversion, 1 inch. 1 foot is 12 inches. I did convert, I didn't have to, but I did in this case. So I got K equivalent of springs, 2 and 3, to be equal to 339.948. So now I have two springs, I can say 1 over K equivalent of 2, 3 is equal to 1 over K2 which is plus 1 over K3, which is 1 over 600. 600 is converting 50 pounds per inch times 12 inches per foot to get it in feet units. Plus 1 over K3. I can solve this because this is 1 over 339.948. I can solve for K3. K3 is equal to 784.31 pounds per foot. That's part C right here. Part C. Find me the spring constant for K3. Now, is there anything on here that we have not discussed in class? Have you seen springs in series? Yeah. Have you seen a block on an incline? Yeah. Have we done problems where you took a moment? Yeah. Have we done a problem where you had a concurrent system of forces that are in equilibrium? Yeah. So, would this be a surprise to you that I would give something like this? Because you have the tools to do this. And you can sit there and say, well, there's nothing like this in the book. Okay. When you go outside the real world, there ain't no book problems. So what are you going to do when you get faced with a problem? You're going to go to your boss and say, well, there's nothing like this that I studied in. I mean, seriously? You're going to sit down and figure it out. Yeah. No, because it said moment at B was 17 points. So that way you change the signs of the forces too. Well, I probably told them in class it was clockwise. As a matter of fact, I'm pretty sure I told them it was clockwise because I see this little arrow right here indicating clockwise. Any other questions on this? Okay. Next problem. Old question number 3. An old question number 3. You can see there's the 3. There's the 3 right there. You can tell that's a question number 3 from the Old Testament. Shift. What do you think is going to happen? I have a 3D problem. First thing I notice is X, Y, Z. Fantastic. Next, I notice double projection. I notice 60, 40, and some missing angles. Right? So that 60 is my alpha. That 40 is my beta. What's missing? Gamma. Right? Then I see a force, AE. So what do I have here? I have all 3 ways of giving information in 3D in one problem. What are the ways? Alpha, beta, gamma, double projection, and distances. right? The 100 pounds is alpha, beta, gamma. The 50 pounds is double projection. And the FAE is the distances, the 5-step process. All three ways are here. Should this surprise you? It shouldn't, because I've already told you. Hey, how many ways can I give it to you? 3. How many ways do you think I'm going to give it to you on the test? 3. Bingo. There it is. Shouldn't shock you, shouldn't surprise you. Next, I see a little dashed line OD. So automatic, I haven't even read the question. You know what the question is. What's the question going to be? Find the forces in Cartesian rectangular Cartesian vector form. That's question number 1. Part A. What's part B? Find a moment about something. Could be O, could be D, could be B, could be whatever. What's question C? Find the component of one of those forces. Which one? It doesn't matter. Find that force about what? Some line. And I probably dashed the line OD because I'm probably going to ask you, find it about OD. What's the 4th one? No. Moment about a specified axis. Probably OD again, since you already have the unit vector OD. Why force you to get another unit vector? Now, the 5th question is, replace the system by single force, single moment. Can the system be reduced down to single force? If so, reduce. And you look at it and you say, 558.532. Yeah, sometimes they throw weird numbers at you. You know what? The real world is not going to have 50 and 100 and 500. You're going to have weird ass numbers. 1.692 tips. It's going to happen. So why can't I use 558.532? Okay. Read the question. Is it what we thought it would be? I'm not shocked. I told you question number 3 is my gift to you. It is intended for you to pick up 10 out of 10, or at least a 9 out of 10. If you do a math error or miss a sign, you might not get 10 out of 10. But its intent is to give you 10 out of 10. And that's the first problem I would start with, because it should be a 10 out of 10. And a strategy on any test is go to the problems that you can collect the most points out of, that you know how to solve right away. It doesn't matter whether you're taking statics, thermo, electrical, dynamics, whatever. Go to the problems and grab the points that you know you can get right away. That should be part of your strategy. You don't start at problem number 1, you start at the problem that gives you the most points, that you know you're going to earn the most points on. That you know that I got this problem down pat. This problem, you know what's coming. Literally, the statement is not going to change. Yeah, FAE and the 50 and the OD might change, but it will say maybe AH or AB or whatever. Okay? So the first things on this one is I need to get all forces and moments in IJK format. Agreed? Okay, let's do that. So first things first, I need this gamma. So I'm going to say cosine squared alpha plus cosine squared beta plus cosine squared gamma equals 1. I have cosine squared of 60 plus cosine squared of 40 plus cosine squared of gamma equals 1. So this is going to say cosine squared gamma is equal to 0.1632. Cosine gamma is equal to plus or minus 0.404 after you take the square root. This is going to tell me gamma 1 is equal to 66.17, or gamma 2 is equal to 113.82. What? 113.82. Now you gotta make a decision. Hey, do I take the acute angle or do I take the obtuse angle? Well, in this case, I'm taking the obtuse. So F1 is automatically 100 times cosine 60i plus cosine 40j plus cosine 113.82k. So F1 is 50i plus 76.604. I try to keep 3 decimals. You should too. Minus 40.399k. There's the first force in IJK format. Next force, I need F2. F2, I'm going to call this one the 50. That's 50, and now I see the line to nowhere sits right here. This will be 50 cosine of 25. Now if I swing it cosine 35, I'll land on the x. So this is going to be 50 times cosine 25, that puts me on the line to nowhere. And then I'm going to swing it cosine 35 to get me to the I, or x-axis. Minus sine 25j, because the opposite is here, and that line is parallel to my y. And then plus cosine 25 sine 35k. So F2 should be 37.120i minus 21.131j plus 25.992k. There's F2 in terms of IJK. F3, we'll call that FAE. Hey, I need the coordinates of E, I need the coordinates of A. Coordinates of A are 0, 12, 0. Coordinates of E are 0, 0, 6. So, RAE is equal to XE minus XAI plus YE minus YAJ plus ZE minus ZAK. RAE vector is 0I minus 12J plus 6K. Magnitude of AE is 13.416. Therefore, FAE, or what I'm going to call F3, is equal to 200 times 0I minus 12J plus 6K. Divide this by 13.416, which will give me 0I minus 178.891J plus 89.445K. Those are all the forces that I see in there. Any problems there? Please notice, this is time consumption. So part of the problem is if you haven't studied well, you haven't prepared enough, you're gonna get to the point where you just say, sit there and pause and look to the sky and think about it. You don't have time to think about it, is what I'm trying to tell you. This is a read, react. Read, react, and write. You don't have time to pause and ponder. If you're pondering, if you're thinking about it, then we have a problem. You did not study well enough. It's got to be recognize and go. Recognize and go. What about the moments? Well, this moment's easy. All I got to do is point my finger in the direction of the double arrow. That's going to be parallel to the y-axis. So that's a J. That's nothing. So this one is M1 is 100 and is going to be minus 150J. What? That was minus 150J. Now this moment right here is on this side of the cube, right? So I have this side of the cube sits right here, and I'm turning this way. Where's my thumb pointing? In the negative x direction, right? So here, I should have an M2 equal to minus 558.532I. That is all forces and moments in terms of IJK. Now I can start answering the question. Moment of the 50-pound force, that's this guy, about the origin. So I want it about here. So I need to go from here to there. So part B, I'm going to write moment about O is equal to R. In this case, this is going to be ROC crossed with F2. That's nothing more than the determinant IJK of ROC. 10I, 0, 0, and this is 37.120 minus 21,131, 25.992. Answer, 0I minus 259.92J minus 211.31K. This, of course, is your MX. This, of course, is your MY. This, of course, is your MZ. So even if I had said, hey, find me the Z component of the moment, I'd still do a moment about O, and my answer would be that. Now, hold on. Now, I know some of you are using your calculators to calculate the cross product. I got no problem with that. However, I do want you to set this up. I need you to set this up. The reason for that is if you come in and you write this and you put a positive sign here, I look over here and I see that's correct. This is wrong. That means somewhere when you plugged it into your calculator, you put in a negative, or you forgot a negative, something happened that you got a positive answer. So if that problem's worth a point, I'm going to take off not a point, but maybe 3/10 or 4/10 of a point because you're fucked up putting it into your calculator. But if you don't do this, and you just give me an answer, and it's wrong, I'm taking the full thing off. So if that's worth a point, you lose a point. So what I'm trying to say to you is, please, if you want me to give partial credit, you must give me enough information to give you partial credit. How do I know if you didn't set this up that you had a math error? Or maybe you just cheated and copied it from somebody next to you. can't prove it because I didn't see it, but at the same time, I don't know it didn't happen. But at least if you give me the determinant, I can say, okay, they know how to set up the determinant. It's a math error, not a status error. Your question?
Can you show again how you got the momentum for the second direction?
How I got what?
The direction for
Momentum? I'm not calculating
The
momentum.
moment, sorry.
For which one?
The
Moment two?
Yes.
So go back to the diagram. There's the diagram. This right here is this right here now. What you see is a clockwise, so I'm going to do a clockwise around this. There's a clockwise. Where's my thumb pointing? That's the negative x direction. Yeah? Okay. That takes care of that. Project FAE onto line OD. Great. This is part C. Projection FAE, which in essence is F3. FAE onto OD. I need unit vector OD dotted with FAE. So I don't have that. I need to get that. Well, what are the coordinates of O? 0, 0, 0. What are the coordinates of D? So O is 0, 0, 0. D has coordinates of 10, 0, 6. So our OD is XD minus XOI plus YD minus YOJ plus ZD minus ZOK. ROD is 10I plus 0J plus 6K. Magnitude of OD is 11.662. So here, I'm going to say 10I plus 0J, and I'm going to do it here. 10I plus 0J plus 6K, divide this by 11.662, and I'm going to dot that with F3 or FAE 0I minus 178.891J plus 59.445K. That's going to give me a value which is a scalar 45.97. Part D says, hey, find me the moment of FAE. Here comes D. The moment about OD is equal to unit vector OD, which I already have, dotted with an R cross FAE. Yeah. I already have unit vector. It's this. I already have this. I broke it down there. I just need an R. What's the R? The R goes from any point on OD to any point on the line of action of the force. Pick one that's easy. Something that is may have zeros in it. So this R has to go from OD, here's OD, to the force. Well, guess what? This could be OA. In other words, that vector. This could be OE. That vector. It could be DA. It could be DE. Any of those will work. So, any of these R's are going to work. they're going from, again, they're going from the line, well, D's on the line, to E, there's DE, and go to DA, and go OA, and go OE. So any of these will work. Your choice. I happen to use OA. So this would be this determinant, 0.857, 0, 0.514. This is 0, 12, 0, 0 minus 178.891, 89.445. Answer, 919.85 pounds, feet, because it's a moment. So I chose ROA. That would be 0, 12, 0. Again, why did I choose that? Because it's got zeros in it. I love zeros. Zeros in a determinant makes the determinant calculation by hand much easier. Okay? With a calculator, it don't matter, pick any of them. But since I do everything by hand, I'm going to pick something that I put zeros in there to make my life easier when I calculate. Okay? Question? Yeah. Say what? What's the question again? I tried to avoid that with you guys. So I just do the R cross F. Yeah. Oh. Okay, so again, you guys are fixating on what happens if I do something like this. So this is on the bottom face of the cube. So this is the bottom face. What do you mean when I use the unit vector? Oh. So if I tell you, let's say I have, instead of the force AE, I have a moment here, AE. Like this. If I give you a moment here, then I'm going to go through the 5-step process for that moment. The 5-step process is for any vector, whether it's a force or a moment or anything else, that I need to go through the 5-step process because I'm given distances at A and E. I'm going to go through the 5-step process. Give me an example. I don't know. You have the testing manual with you? Well, then I can't answer the question because I don't know what you're looking at. You have the testing manual? Here. Find the download question and let me be able to answer intelligently. Next. Hey, reduce this thing to a single force at B. Well, a single force at B wipes that guy out. Right? Because it's acting at B, so I don't have to worry about that force. So here we go. I'm going to do moment at B is equal to. Well, first of all, let's do single force resultant. That would be F1 plus F2 plus F3. Add up I's, add up J's, add up K's. That would give me 87.12 I minus 123.418 J plus 75.038 K. I try to keep 3 decimal places. This was 0. Moment at B resultant. Well, I got minus 150J. That was a moment that already existed. I got minus 558.532 I. I have 2 forces that are creating moments. What? I have 2 forces that are creating moments. F2 and F3 or FAE. That would be RBA crossed with FAE plus RBC crossed with F2. So these are already moments, you just dump them in. These are two forces that are creating moments at B. The other force is at B, creates no moment because its line of action goes through B. So let's look at the diagram so you can see what I'm doing. So I'm taking moments here. So I need, for FAE, I'm going from B to A. There's my RBA. To get to this guy, I'm going to go RBC. So they're pretty easy R's. So here, I'm going to set up a determinant that says IJK of minus 10, 0, 0, 0, minus 178.891, and 89.445. This one, I'm setting up a determinant that looks like IJK 0 minus 12, 0, 37.12, minus 21.131, and 25.992. Do the determinants, add up i's, add up j's, you're going to get an MV resultant, which is minus 870.436i plus 744.45j plus 2234.35k. There's my single moment. There's my single force. Moment B resultant done with F resultant, does that equal 0? No. It will reduce, it is not reducible to a single force. That is question number 3 on the test. Yes, you are going to have the same exact words, but the diagram is going to look different. That's the very first problem you should do. Pick up your 10 out of 10 and move on. After that, my suggestion would be to do, and it doesn't matter. Question number 1 is either going to be a resultant 3D or an equilibrium 3D. And of course, question number 2 is going to be your crazy ass moments and lots of inclines and series and parallel and pulleys and blah blah blah. What about it? Yeah, at 14, yeah, you can't see it very well. That 14, I'm going to do IJK. I'm going to do position vector. Who's going? Question. Remember, we are starting equilibrium, chapter 5, next week.